Hi again, Captain Peter Cutsie with another of my online briefings. Today we're going to talk about the Integrated Approach Navigation, IAN. So this is what we're going to look at in a minute or two, but we'll start off with something that we should be always thinking about with the modern aircraft and technology is think of the raw data that you have on your instrument panel as a cake, and the magenta command bars and all the magenta as being the icing on the cake. Remember, the icing is extra. We have to focus on the cake. We have to stay with raw data as the basis of all our flying and use the icing to assist us making our decisions. From the, we'll go to a PowerPoint here and start off with what is IAN, a navigation enhancement that capitalizes on the 737 FMC and auto flight system capabilities. It's a mode that melds FMC derived course and glide path tools with the ILS mode of operation for procedural consistency among various approach categories. In other words, the information is coming from the FMC, not from an ILS transmitter as far as the localizer is concerned or the glide path is concerned. On an ILS, what we're going to be looking at in IAN is a lookalike, but the information is coming from the FMC. So we'll go back and have a look at some of the key benefits. There is commonality of procedures. It's very much like an ILS as far as the procedures are concerned. Reduced training time, commonality of displays, ILS type, improved deviation indicators over LNAV, VNAV. Now, having said that, you would probably be on vectors for an EN approach, or you could be, in many cases, using LNAV, VNAV and transition from LNAV, VNAV to an EN approach. We'll have a look at a little video in the very shortly. A non-ILS Category 1 VOR NDB capability with ILS display, digital flight control system control laws, glide path priority over MCP altitude window, enhanced protections and warnings over VNAV, glide path signal anomaly detection, oral glide slope warning and below glide slope inhibit light, flashing amber scale and pointer when excessive deviation with the autopilot engaged, and oral and visual autopilot warnings. So these are good enhancements. Now, the IAN, this is important, and your instructor will demonstrate this in your sim session, is the loading of EAN. So select the ILS frequency. The ILS frequency, and let's say, for an example, 109.5, must be selected if the ILS localizer course is to be used, including an ILS, localizer, back course, SDF, or LDA approaches. So the ILS frequency must be selected if the localizer course is to be used in any one of these approaches: ILS, localizer, back course, SDF, or LDA. On all approaches other than those just mentioned, the appropriate VOR, the area VOR for that airport, frequency must be selected. So that is actually how you're going to load EN, providing that feature has been loaded in your particular fleet. It may not be loaded, but your SOPs and your company will train you in accordance with that if EN is already loaded in your aircraft. Now, in other words, if the final approach course guidance will come up from the localizer, the ILS frequency must be tuned. If from the FMC, that is the information to IAN is from the FMC, then a VOR frequency must be tuned, even though it will not be used for guidance, raw data in some cases. So this is probably the most important part of this entire briefing, because the rest of what you're going to see in the video is almost identical to an ILS. Okay, now one of the things that we take for granted and we shouldn't is if your AMP is within the RMP requirements for the approach, you will have the indication on progress 4.4 of the FMC CDU, but on the lower part of your nav display, you will actually see the RMP for that part of the approach, which is basically 0.3 from the final fix inbound, and the actual navigation performance, probably in most cases showing as 0.05. And here's a little picture of it. If this is the limit of the RMP of 0.3 nautical miles, either side of your approach course, then you will be in the green, meaning that you're within the limits. If, however, you should exceed the limits, here you are, here's your airplane. Remember, this is your track, actual track generated from the IRS on your nav display. And this is the raw data I was talking about at the very beginning. Well, you've got to be using that raw data. And this airplane and the 30-second trend vector, in this particular case, the tip of the aircraft is outside of the required navigation performance for that portion of the approach. Remember, the AMP will vary from 2 nautical miles to 1 nautical mile to 0.3 nautical miles, depending on how far out from the runway you are. So it's very important that you monitor the actual movement of the magenta line away from the tip of the aircraft symbol. As the magenta line starts moving away from the magenta line, the actual navigation performance, ANP, will increase. And once it goes beyond the required navigation performance, then you will get a message here, I should say a message on the CDU scratch pad as far as navigation performance is concerned. And you'll also get these indications on your nav display changing color. So you've got to monitor this continually. If the airplane's starting to turn, there's a reason why it's turning. If the wind speed, direction and speed is constant in your descent on the approach, and the airplane starts turning to follow the magenta line, you can really smell a rat, pardon the expression, because probably the actual navigation performance is increasing. It still may be in the green. If the airplane symbol was here, it would still be in the green, but you can actually, why is it changing? Do you have inaccurate information coming to the FMC? And if you are, now's the time to stop it. In other words, go around. You would never allow yourself to get to this point. If you do, you're not doing your job as a pilot. And remember, these indications, readouts for the required navigation performance and actual navigation performance are very tiny. And they are at the bottom of the nav display. They're also on progress page 4.4. Progress page 2.4 and progress page 4.4 are invaluable for all approaches. So that's why I wanted to point that out to you. So it's very important you monitor that. Let's get into what the FCTM says about some of the items it says. There's very little actually in the Boeing manuals. And the video that you're going to see shortly will explain it all. In any case, specific types of approaches are stabilized if they also fulfill the following. Approaches using EN should be flown within 1 dot of the glide path and the FAC, which is the final approach course. That's important. Now, another item in the FCTM, and I've highlighted it, are that a mandatory missed approach, you must initiate a missed approach on all instrument approaches where a suitable visual reference has not been established and maintained. Execute an immediate missed approach when navigation, radio, or flight instrument failure occurs, which affects the ability to safely complete the approach. That RMP, AMP is just one example. The navigation instrument shows significant disagreement. Again, RMP, AMP have to be in the green, and they shouldn't be changing. On ILS or GLS final approach, and either the localizer or glide slope indicator shows full deflection. Now, one that applies for us is on a NEAN approach, and either the FAC, final approach course pointer, or the glide path, GP, pointer shows full deflection. You must carry out a missed approach. On an RMP-based approach, and an alert message indicates that our AMP exceeds RMP. We just talked about that. And for airplanes with the navigation performance scales during RMP approach operation, anytime the NPS deviation exceeds the limit or an amber deviation alert occurs, unless the aircrew is able to change to a non-RMP procedure. Now listen, you're not going to change to a non-RMP procedure unless you're briefed on it. And it could cause massive confusion. My recommendation, although it says so here in the FCTM, you've got to use your head. Airmanship dictates if you have a problem on an approach, go around. Go into a holding pattern and talk about it. Now, if your map is not right, or as we mentioned at the beginning of this briefing, you're going to have to go to a raw data and establish perhaps holding at a VOR using raw data if your map is inaccurate. Now that's called airmanship. Decide what you're going to do and come back and do an approach other than an EAN approach, perhaps an LNAV, VNAV approach, or using a localizer or whatever you've been trained to do. So be very, very careful with this statement here. Go and talk about it. So go around. And lastly, for airplanes without the navigation performance scales, during an RMP operation, anytime the cross-track exceeds 1 times the RMP, unless the aircrew is able to change to a non-RMP procedure. And again, if you're going to change to a non-RMP procedure, make sure you go around, get into a holding pattern, talk about it, and then set up an approach that doesn't require RMP. Now that's very important. That's directly from the FCTM with my suggestions using airmanship. The FCOM, Boeing's FCOM, stipulate actually a landing procedure, and initially the pilot flying, if on a radar vector, you would be in heading select, of course. And if you're using LNAV or VNAV, well, you're going to transition, as I mentioned, from LNAV to VNAV. The call for flaps as you normally would according to the profile. And when on the localizer final approach course, intercept heading, verify that the navigation radios are tuned and identified. Now, this is important. Remember what we talked about at the very beginning. If you're going to be using the localizer, fine. Otherwise, you have to have a VOR tuned. Otherwise, you're not going to get the information up on the PFD. Very important. Use LNAV or heading select to intercept the final approach course. May I recommend that as you're getting close to the final approach course to switch to, now that the drift has been established, to switch to a heading select, because using LNAV may cause problems in the transition to a localizer. So I recommend you use heading select as you get close for the intercept heading. Verify that the localizer final approach course is captured, and verify that the final approach course heading. So you would set that up, of course, on the MCP. A recommendation is approximately 2 miles before the final approach fix. Call for the approaching glide path. So approaching glide path, at which time the pilot flying will call for gear down flaps 15. The reason being is the glide path on the EN comes into view very quickly, and you don't get enough lead time, because remember, it's generated from the FMC, and it's not the same as a glide path transmitter using an ILS. So we recommend that, and I would recommend that on the fixed page, put a 2 nautical mile arc to give you a 2 nautical mile lead to the final approach fix, at which time you can call for gear down flaps 15. And then carry on and fly the approach as you would normally, as very similar to an ILS. And that's what's recommended here. Now let's just go and have a quick look at a video that I thought was extremely well done. And it's not my work, but I think it was extremely well done, and I'm going to use it just for a quick reference. And I've muted the sound, and I will add my comments as we can watch the video. The person who did it did a super job, and on the bottom has had the text. But try to focus on the FMA throughout this as I'm speaking. So here we are at level at 3,000 feet, and we have an indication here that we actually, in fact, have the EN approach has been selected. We're using the autopilot and engaging approach with the, all the correct information set up the way I briefed will give you a green light on the MCP light switch, and you will have FAC armed and glide path armed. Command that the autopilot is engaged. And this is the simulated glide path, very similar to an ILS. And here we are, LNAV, VNAV, and we're going to be transitioning to a final approach course in EN. Here is the glide path, and here is the localizer, very similar to the ILS. Remember, this information here indicates that we've actually selected and EN. We have the approach courses set of 2, 3, 4 for this approach to runway. It's actually a VOR approach to runway 23 left. So this is telling us that the information is coming from the FMC, because it says so, FMC. So it's all being generated from the FMC as we are proceeding along. Here's our radio altimeter, and here, of course, is the final approach course has been captured. All right, and it's changed to green. We're still in altitude hold, level at 3,000 feet, with one autopilot engaged. All right, and we're monitoring everything. Here is the FAC, the final approach course, coming into view and for alignment, and looking very much like an ILS. All right, and we are at flaps 5, I believe in this video that he's got selected, and we're at 170 knots. And we're looking good. We're at 2,440 feet. Radio altimeter is alive, and you're monitoring that as you would always, of course. So now here, the approach, of course, is armed as we did before, and the glide path is armed, and we're at 3,000 feet, and very soon we'll be intercepting the glide slope and we'll be starting down. So we can watch that as it's happening. Single channel, okay, in green, and glide path capture. In green, glide path, single channel. The reason why it's green right away is there are no other selections that would happen after. That's why it went to green rather than amber. And here we are on the glide slope, and we're descending at a good rate of descent, 850 feet per minute. And as I mentioned before, single channel, green. So that's a clue that you are using EN. So FAC, glide path, single channel mean you are executing an EN approach. And of course, don't forget your radio altimeter. And you'd be also looking at your nav display, which we don't have in this video, and making sure that the RNP and AMP are within the proper limits. Very, very important. And this is our minimum here. And as I mentioned before, we're looking very much the same as an ILS. We've taken our final flap setting, and we are setting our bug speed, VREF +5, and we are out of 1,870 feet above the ground, leaving 2,000 feet roughly above sea level. Now, so that is basically it. We'll continue on through to the approach and landing. There's your flap setting at flap 30, your flap lever, and there is your glide path reference and the test, self-test, very similar to the ILS. So that part of the software was integrated in EN, important to know, and that's why it was designed that way, a look-alike to an ILS. But remember, the information is coming from the FMC. Important to know that. All right. So, and your missed approach altitude has been set, 3,000 feet. And we're coming up to 1,000 feet above ground, and there's the white indication on the PFD indicating that you are between 1,000 feet and 500 feet above the ground. So that was introduced also into the software. When we get down to 500 feet, the bar will turn to amber. Here we are at 690 feet. There's the amber coming up. So at 500 feet on the radio altitude, the amber bar will be in view at the horizon line to indicate that we are below 500 feet, and we are indeed. Our rate of descent still looking good at about 850 feet per minute. For this airspeed, looks good. And the power setting is good also. So we are going to be coming up to our minimum soon. And autopilot is announced over the flight deck speaker if you had a problem. That is, if you didn't disengage it below 100 feet, it would come on to remind you that you should be disengaging the autopilot before you land. So there you go, folks. A great person. Congrats to the lovely video. Not my work, but really extremely well done. And I thought I'd use it in this presentation. If you want any kind of a briefing at all, my information is at the top of the screen. You can call me or email me, and we can set up a briefing for you and your partner on Zoom, and before you go into the simulator for your own session. Thanks again.